Hi, I'm Meta Spencer. I'm thrilled to say that today we're going to a beautiful city in England, Cambridge, and we're going to talk to somebody who is running an outfit that I want to know more about. I'm looking forward to a conversation with Dr. Sean Fitzgerald, who's the director of something called the Center for Climate Repair at the University of Cambridge. Good morning, Dr. Fitzgerald.
Good morning to you, Meta.
It's a pleasure to have an opportunity to get acquainted with the wonderful work that's going on in England, especially at your center, at least I think, especially at your center. I'm not sure what all you do. So that's really what I hope we can do today, is sort of get acquainted with what is happening in terms of the academic and other research going on to try to promote solutions to global warming. And I know that your institute, I love the title, Climate Repair. And I think if we talk about it that way, we would understand that from now on this planet, we're going to have a system for managing the climate. And it's not going to be something that will take care of itself automatically. So we're going to have to constantly monitor what the weather is like and what's going on. So I'm glad to know that you've found the right terminology to talk about this project. So tell me about your work, and tell me, I have never been to Cambridge, as a matter of fact, and I've been to Oxford, but I think you're rivals, aren't you? Tell me about the Institute, how long you've existed, and what kinds of research you do there. I know you have a big staff. I looked at your website, and you have a lot of folks doing work there.
Well, so the centre was established about 4 years ago within the city of Cambridge. We were set up at the beginning in one of our colleges called Downing College. And the purpose of the Centre for Climate Repair is indeed to try and repair the climate, or at least provide the understanding for everyone to then help repair the climate. We're not going to do this on our own. And you're right, it's an interesting framing of the challenge ahead of us. But although it's a positive tone in terms of the action of repair, it's something that we can do. It's also recognizing that it's not going to be restoring it to its former state. So when you've broken a bone, that bone actually will still have, if you really wanted to dissect it, you could really sort of see where there was a previous fracture. And that means that, we're going to make things better, but not necessarily going to restore it to its former state. And that's just recognizing the fact that, there are certain things that have changed that we're going to be very, very difficult to reverse. So, for example, even though we haven't lost a huge amount of ice from Greenland and or Antarctica, when that ice goes, it's really, really difficult to think about how long it would take for that ice to then be replenished. Ultimately, it would be to do with snowfall and building up an ice pack again. So those are very, very long time scales. What we're interested, though, is indeed repairing the climate. And our ultimate objective is to try and get greenhouse gas levels down to something like 350 parts per million carbon dioxide equivalent. Today, levels are about 420 parts per million of carbon dioxide alone. And if you then throw in other greenhouse gases, such as methane, and depending on what time scale you wish to sort of equilibrate that to in terms of carbon dioxide equivalents, then we are something like 500 parts per million carbon dioxide equivalent today.
Really?
And our objective is, look, let's get it back down to 350, recognizing that pre-industrial levels were about 270. So we're not going back to pre-industrial levels in terms of where we think the world. But James Hansen has gone on record by saying that he thinks this is about the level which would allow humanity and ecosystems to continue hereafter. Now, the purpose of the Centre for Climate Repair is to help map out a pathway as to how we get there, whilst also keeping the ice on Greenland, the ice on Antarctica, so we don't have catastrophic sea level rise over the next hundreds of years. And the three big levers that we think are necessary, I'll start with the blindingly obvious, is to stop the problem getting any worse. So we've got to reduce emissions.
Mm-hmm.
The reality, unfortunately, is twofold. Firstly, that we're making actually very slow progress on reducing emissions. But secondly,
in fact, I think the emissions are increasing.
Well, the best that we can claim at the moment is I think that we've reduced the rate at which they are increasing. So this is hardly something to be overly proud about, but let's give credit where credit is perhaps due. But we've got to reduce emissions, but we're not going to reduce them to zero. And that is because of various factors, such as just how we produce food, and therefore the emissions associated with our activity on feeding, let's say, 7-8 billion people on the earth. And there are greenhouse gases being emitted through our agricultural practices that we can't take to zero. So we're going to need to introduce greenhouse gas removal approaches in order to compensate for those emissions. And that's where we hear the term net zero being bandied around. So reducing emissions and then introducing greenhouse gas removal approaches in order to at least get to net zero. But the second R, the first one being reducing emissions, the second R is removing greenhouse gases. We've got to go a lot harder on the second R than just being able to get to net zero. We've got to undo the damage that we've already inflicted on the climate, and that means we've got to draw down greenhouse gases even from their current level. So our second R is removing of greenhouse gases, and our third R we call refreeze, but it's introducing the idea that there are certain activities that we might be able to undertake in order to get temperatures down in a intermediate period whilst we get the greenhouse gas levels down, and still being able to keep the ice on Antarctica, still being able to keep the ice on Greenland, and ideally still being able to keep, for example, sea ice in the Arctic, which itself provides a wonderful reflective blanket in the summer to reflect some of the sun's radiation away from the ocean. So we call that refreeze. And we've got research going on at the University of Cambridge in collaboration with a number of other institutions around the world that is multidisciplinary, not just looking at physical and biological sciences, but looking at the social sciences, looking at the legal frameworks, certainly the acceptability issues of some of these areas, because there are people around who would just think that we should just be allowed to and all focus all of our efforts on emissions reduction. But when
My goodness, you put it delicately, because it's not just there are a few people like that. That is the overwhelming majority of the people that I encounter. People saying, we just do emission reduction, and after maybe 50 years we'll talk about something else. But I'm glad to see that you have the foresight to realize that we need to do both right now.
Well, I mean, it's not just us in Cambridge who have the foresight to do that. Let's be clear, Meta. So, the actions, for example, of bioenergy carbon capture storage, which is a form of greenhouse gas removal, is cited in the IPCC reports and included in some of the scenarios that they consider in their future mapping. So the second R of greenhouse gas removal is already in the conversation and actually part of the scenarios already considered by those august bodies. The third R on refreeze, that isn't yet something that's considered in the scenarios that are presented to us by the IPCC. But perhaps in the near future, it may well be. And it's in terms of the conversations that I've had with various people associated with those sort of activities in terms of what the modelling, there are definitely discussions going on right now as to whether they should create a chapter including some of these options. But let's be really clear, those options do not exist in practice right now. We do not have the technology, we do not have the proof, we certainly don't have proven acceptability for these. Nevertheless, the purpose of scenarios in the IPCC modelling is not, those are not forecasts, those are just potential futures that one might wish to consider. And I therefore think it would be appropriate to at least include some of those ideas in within a future IPCC report. But the work at the University of Cambridge, is on all three of those R's. The Centre for Climate Repair is now
Mhm.
focusing most of its research efforts on the second two R's, recognizing that there is already a lot of work on deployment for reducing emissions, and also a lot of research looking at new ways of reducing emissions. But there are bigger gaps on the second two R's, and that's where we feel, therefore, we can have the biggest
Mhm.
contribution to make to society by furthering knowledge in those areas and collaborating on a multinational level with key universities and non-academics around the world.
Well, your priorities are exactly right, I think. And in fact, they're completely consistent with what we're trying to do in Projects Save the World. And I think you may have heard from Hugh Hunt that we will be offering a series of 35 shows similar to this over the next 8 months, one almost every Monday, in which we invite various experts in to talk about primarily about the technologies that might be available for refreezing the Arctic and conceivably the Antarctic. I don't know about that, and other ways of cooling the planet and removing greenhouse gas. So we're looking at what is. I don't mind using the word geoengineering, but I wish that the world had already previously adopted your term, climate repair, because I think it's going to require some technological interventions, and we want to discuss this thoroughly. My notion is that indeed public opinion right now is not ready to talk about this very much, and all we have to do to be useful right now, our contribution is to try to stimulate more concern about it in the public discourse, to get people talking about it. Because as soon as they listen to the experts who are thinking about these technological solutions, mostly the tendency is to take it seriously and move in the direction of maybe accepting it and even promoting it. Tell me if that is your impression.
Well, it is, but also in terms of, the way the conversation unfolds is really important. And one of the classic arguments that we hear for those who sort of wish to think that the actions should all be and only be on emissions reduction is this term called the moral hazard,
Yeah.
whereby the framing is this, the argument is this, that if you decide to go and focus some efforts on something other than emissions reduction, so for example greenhouse gas removal,
Mhm.
then there's a fear, and it is something that exercises me, that there will be a weakening of resolve in our efforts to reduce emissions. And it does concern me greatly that whatever we do, we should not have as an excuse to weaken our resolve on reducing emissions. We've got to do everything that we absolutely can. And, I've reflected on this. And what about adaptation? So what about, designing crops that are going to be more resilient to more frequent and certainly more severe weather events? Is that a good thing or a bad thing when we're talking about hunger and, for various countries, perhaps even worldwide hunger, but certainly for certain countries? And the conversation now is that some of these research programs where we're looking at new ways of adapting to a new climate are very sensible. But is the action and the work that we have regarding developing our understanding and figuring out ways to adapt to a new climate, is that going to weaken our resolve on reducing emissions?
That hadn't even occurred to me when it comes to things like developing new strains of grains and so on. But I do feel I have an opinion on that subject. My impression is that it all depends on who you're talking to. I don't think the general public has any trouble with the moral hazard. I think it's oil companies. I think it's people who have vested interest in delaying any transition to other, slowing the use of fossil fuels, because they will use every excuse they can get, we know. But the average person understands without any difficulty that if your bathtub is about to overflow, it's okay to both turn off the tap and pull the plug. You don't have to worry about which you do first or whether by doing one you're going to undermine the effort to do the other, anything of that kind. Everybody can understand that both of them are needed and perfectly compatible, and do it, just get on with it. And I think ordinary people have no trouble with moral hazard. I think it's that they may be susceptible to the influence of propaganda people or PR people from fossil fuel interests.
Well, I mean, so I'm, of the mind that, I will accept that there is a moral hazard um, argument and that there is a moral hazard risk. I'm not going to dismiss that. I think, let's that in fact accept that that is reality. However, on the other side of the coin, I would also listen to other people who have a different view, and especially, for example, those who are going to be most affected by the relatively near-term effects of climate change and who are least able to adapt and withstand those effects. And I had the great privilege back in December 2023 of attending COP28 in Dubai and listening to the United Nations ambassador to the islands of Palau, a lady called Ilona Said, very eloquent and really an amazing speech where we were talking about, in this case, it was looking at the potential research project called Seabed Curtains to try and protect glaciers, especially those in Antarctica, and to try and keep the ice on Antarctica. And her argument was as follows, that my people, we live in the islands of Palau, which are in the Pacific Ocean. And she said, for my people, a 1 or 2 meter rise in sea level is not a case of just losing a bit of beach. We have atolls. That's where we live. She said, we have no country. We have no country. And therefore they'll have a loss of culture and everything like that. Come and talk to my people about, no, we don't want to do any research in the development of ideas such as seabed curtains. We're just going to continue putting our efforts into the reduction of greenhouse gas emissions. And I think some of these more minority groups, and then by saying minority because they're just not a large group of people, they need a big seat at the table when it comes to figuring out actually what the right things to be doing are. And I have to listen to those arguments as well as those who express concerns about the potential for weakening of resolve in emissions reduction. And then lastly, why have we made such slow progress in reducing emissions? We've known about the problem for climate change for, 30 years. Is it because of the prospect, the promise perhaps, of things like geoengineering, a term that you used, Mette? Is that what has caused our very, very poor progress in?
No.
Of course, I don't think it is. Certainly 30 years ago, this was not on the table.
Yeah.
So, it seems challenging to introduce this as the reason for the poor progress we've made. Don't get me wrong, I think we need to work a lot harder on reducing emissions. It's the number one priority.
Yes.
But to then say that we should not be undertaking even research in some of these other areas, I find challenging. And it's not just me that finds it challenging. It's also the people from the islands of Palau that find that challenging too.
Absolutely. I did an interview with the ambassador to the UN from Tuvalu. And his story, of course, is completely consistent with the Palau problem. Okay, let's talk about the research that you are doing there, because there are a number of different technologies. The series of conversations that I'm planning mostly focus on about 4 interventions. One being marine cloud brightening, one being ocean iron fertilization, one being iron salt aerosol, and the fourth being kind of a far out idea so far, which I don't know whether it has legs, and that is thinning the cirrus clouds and letting heat out the top of the poles. I know that there are a number of other um, uh, proposals that have been made with varying degrees of convincingness. And it may be that you're looking into some other possible technological solutions. One of the far out ones that we will consider briefly in the series is saving the whales, because it turns out that the whales have an important thing to do in stirring up the ocean and fertilizing it with their whale poop. So that's not a major part of the equation, but it's one of the little things that we can tuck in with the others. Tell me what all you're investigating at Cambridge.
So, I mean, we're looking at a number of the ones that you've mentioned. So, first of all, we are looking at marine cloud brightening. I'll tell you a bit about that in just a moment. We are looking at the role of nutrients within the ocean, and actually do need to supply some additional nutrients. You can call it ocean iron fertilization, which is generally a term that's used to consider what the immediate impact of that is regarding carbon dioxide sequestration over relatively short timescales. We're looking at that problem in a slightly different framing and over a different timescale by what we might be able to do to help regenerate ecosystems in certain parts of the ocean. And the mechanism by which you reintroduce ecosystems may well be through the provision of nutrients. So it's a slightly different framing. And we are looking at cirrus cloud thinning. From a modeling point of view, we're not doing work on iron salt aerosols, so those are your four. But the other areas that we're looking at in the greenhouse gas removal space, we're looking at the role of giant kelp and other seaweeds in the ocean, in particular the surface waters of the deep ocean. We are looking at the role of materials to help accelerate the oxidation of methane in the atmosphere. I mean, in other words, if we can convert the methane into carbon dioxide, and it'll still be in the atmosphere, unless you've done something by trapping it and disposing of it, that will have a sort of fairly immediate impact on the
Now, I
climate.
thought that's what I would think of as the iron salt aerosol.
That's one way of tackling methane, but we're looking at development of materials, for example, catalysts, so solid materials rather than gaseous. So rather than spraying things into the atmosphere and radicals, using photocatalysts and electrocatalysts to do that.
Well, I'd like to know more about that, because that one is alien to me. I haven't heard about it.
So I'll come back to these, and then we are also looking at the way to get more ice to grow in the Arctic winter over the Arctic Sea. So we call that ice thickening, and the action of pumping seawater on top of sea ice. Are there certain ways that might be able to grow more sea ice in the Arctic winter, so it will then last longer over the Arctic summer? I've already mentioned the sort of seabed curtains, so trying to look at the erection of barriers on the ocean floor near glaciers to reduce the rate of ingress of warm saline water that at the moment is increasing the rate of erosion of glaciers, especially in some parts of Antarctica, Western Antarctica, if we were to create some form of barrier.
I think maybe we're talking about the same thing there, because I interviewed a man about that idea. There's a certain inlet or place in Antarctica that is crucial, and he wants to put some sort of curtain barrier to keep the warm water out. Is that the proposal that you have in mind, or is there another one?
No, indeed. And was that John Moore that you spoke with?
It sounds right. Yeah.
Okay. So no, we are collaborating with John. They've done some amazing modeling and amazing work. But what we're doing is doing some laboratory experiments and helping on the engineering aspect of that particular problem. And that as a hallmark is true for all of the research that we do, is we try and collaborate with others around the world and identify where we can most add value. And in Cambridge, for some other projects, it's on the engineering side. So we're doing some lab modeling of physical structures in background currents, looking at how they behave and what therefore the kinds of forces that those sorts of structures might be subjected to. which are difficult to model just using numerical modeling because of the shedding of vortices, the instabilities that might arise on some of these structures, and therefore the occurrence of flutter. What does that actually do to the vibrations of these particular structures? And what does it actually therefore do to currents as well? And then on marine cloud brightening, we also have an engineering sort of bend to what we're doing. We're looking in particular at how one might be able to generate saltwater droplets that are more uniform in size, so a narrower size range, because the modeling work that's been done by many others around the world with whom we collaborate is identifying that there seems to be a Goldilocks range of droplets that's needed, and the current methods used for droplet generation appear to be generating droplets of quite a wide size range. Now, not only is that quite hungry in terms of energy, so energy intensive, it also carries risks associated with it in terms of what it actually does to the clouds. So if you have too many small, really small droplets, there's a possibility that you can cause more evaporation of the clouds and turn some of the cloud into a haze and reduce the reflectivity. Or you might end up turning that cloud, and if the droplets are too large, into sort of very large droplets, in which case you might make the cloud a bit darker and it might even rain out sooner. And therefore you've clearly not helped things at all. You've reduced the reflectivity, whereas the whole purpose is to brighten clouds. Therefore, we're looking at a range of different droplet generation techniques here at the university.
Well, not only that, but I understand that the nozzle, designing the right kind of nozzle, is still a work in progress. That they don't really have a reliable nozzle. Is that correct?
That is completely correct, and that's why we're contributing to the field in that particular area. In terms of the engineering, looking at completely different ways of generating droplets, whether it's using air and water, whether it's using electrostatic charges, whether it's using just very high pressure through and with a vibrating pressure pulse behind very small holes. So there are lots and lots of different ways that one might be able to generate droplets that we're investigating.
I'd like to know more about that because I'm not aware of these alternative methods that you're following. I think, do you have some connection with the project on the Great Barrier Reef? I interviewed this fellow a couple of years ago who was working on that, and I thought there was some relationship between Cambridge and that project. How is that going, if you know?
So was that Dan Harrison that you interviewed? Well, Dan's a very dear colleague, and we have a postdoctoral researcher at the University of Cambridge right now. I say he's at the University of Cambridge. He's employed by the University of Cambridge. But this month, he's actually with Dan on the Great Barrier Reef. They are doing a campaign and trialing another droplet generation technique and collecting even more data on this particular trip. So we're supporting that project significantly, but most of the work that we are doing on that project is helping Dan in figuring out, are there different droplet generation techniques that will be better than the nebulizer kind of idea that they're currently using within their field trials. So we're providing some first and foremost engineering expertise, but they're leading that project. They're leading the fieldwork campaign and engaging with the stakeholders. They're involving local people in the experiments, and we're providing, one of the ingredients to a bigger research effort, which is being led by Dan. And that's really a theme for what we're doing at the University of Cambridge, which is to try and collaborate with others. On some projects we might well lead, and on others we will provide a supporting agency to a particular research project.
Well, that's wonderful. And I was, when I talked to him, I was saying, hurry, because, I tried to organize a discussion about ways in which Canada could contribute by implementing several different global warming solutions. They're not all for the Arctic, but I'm focusing on work now for the Arctic. But But also, I think that the problem is we want to get it done right away. I'd love to have a pilot project starting, in a year or two, and that's not possible when it comes to Marine Cloud Lightning because the nozzles aren't there yet, and we got to figure out how to disperse the stuff. And one of the issues that we are sometimes disputing in my conversations is whether or not marine cloud brightening is at all suitable for the Arctic. I just did a show on Monday in which we talked about that topic of marine cloud brightening. And I always try to invite somebody onto the show who's not part of the research team, and therefore who'll be either a little bit critical or at least hold people's feet to the fire when it comes to evidence. And my friend Adele Buckley was quite concerned about the notion of using marine cloud brightening in the Arctic because she says that's not the best place to do it. Well, that's true. It'd be better and easier to do it at someplace warmer, but that's where it's needed most. And I don't know whether we will be able to do anything in the Arctic materially and on the ground or on the ice within the next 5 years. Do you think so? Is there anything coming up that we can expect to actually do a pilot study of?
So, I mean, the general point about trying to protect the Arctic and where you might therefore act is a really important question. And indeed, so marine cloud brightening in the Arctic may not be the best way to use marine cloud brightening to help the Arctic. It might well not be. It may well be that sort of marine cloud brightening much further south in different areas, which will then have a knock-on effect and therefore help the Arctic, might be rather more effective. And that's what the modelling work in particular is able to teach us, the modelling work done by various groups around the world. But in the Arctic itself, we have another project called ice thickening. So, is there a way to get more sea ice to grow in the Arctic winter? And one way that has been proposed is to pump seawater on top of sea ice, and therefore allow the freezing of the seawater to occur on the top of the sea ice rather than underneath the sea ice. And the main reason why you get more ice to actually form as a result of this action is because as the ice thickens over the winter, the ice floats, and the new ice being formed is on the bottom of the sea ice. But the sea ice itself acts as an insulator, and therefore, ultimately, the heat being released through the solidification process has to get out to space. It's going to be radiated out to space in the Arctic winter. So you've got to conduct that heat, or nature's got to conduct that heat from the bottom of the sea ice to the top of the sea ice. So as the sea ice thickens, everything else being equal, the rate at which new ice is forming decreases. So the big idea is pump seawater on top of the sea ice. You're now not blocked by the insulating blanket. Therefore, you'll be going to
Right. When I heard about that proposal a couple of years ago, I think it's actually similar to the technology that's used in ice rinks,
absolutely
skating rinks. They spray the top of the ice every now and then, and that thickens it and keeps it going. But I had tried to set up a conversation with, I think, 3 guys in UK who were promoting that, and before we could actually do a talk show. They changed their mind. They said they're not ready to talk. And I think they actually began to doubt their own research, whether or not it would work.
So I'm a proponent of furthering research into this idea. I am not at the moment saying that this is a way to get more ice into the Arctic. I don't know, right? And the reason is this, is that although the action of pumping seawater on top of sea ice from the modelling point of view, looks as if you can get more ice to form over the Arctic winter. The challenge is that the kind of ice that you've then created may well be, and we think it probably is, saltier than the ice that would have formed naturally. So you've changed, in all likelihood, the melting temperature of that ice. So you've grown more of it, but it's a different kind of ice. And we've got to try and understand whether the upside of growing more ice is a bigger effect than the fact that you may have changed the melting temperature of the ice assembly that you've created. So at the moment, the jury is out as to whether this is a good idea or not. We've been doing some modeling as well as some laboratory experiments, looking literally at what happens when you pour water onto ice and then salt water onto ice as well. We're doing laboratory experiments here at the University of Cambridge, and we're in collaboration with a group called Real Ice. They can be found on LinkedIn.
Those are the people that I talked to and wanted to interview.
Yeah, so the gentleman or the team from Real Ice, we're working with them, and PhD student Jacob Pantling has literally just returned from a trip up to the Canadian High Arctic Research Station in Cambridge Bay, where they have been pumping seawater on top of sea ice and collecting data, because at the moment we're interested in trying to learn actually what happens when you pump seawater on top of sea ice, and as in this case, the sea ice itself has got a snow layer on top of it as well. So they're interested in the first and foremost, which I think is a very sensible question, as to actually what happens when you pump seawater onto snow that's on top of ice, and how does that behave? What does that do? And the advantage of basically consolidating the snow, so changing it from snow to ice, is the thermal conductivity of that layer then increases, because snow is an even better insulator than solid ice. Yeah, if we thought solid ice was hurting us, snow hurts us even more when it comes to heat transfer. Certainly during the winter, it might be quite helpful in the summer, as it turns out. But what we want to do, in other words, to protect the sea ice, but what we want to do is to look at the effects, therefore, of flooding the snow and then allowing it to freeze and turn that into ice. That's part of the sort of the research program, and that's going on in earnest at the moment. And if we find that this is a sensible thing to do, then certainly within 5 years, and we will be in a position to be able to say, actually, we think we should be scaling this up or not. But it won't be for us to decide whether it should then be scaled up or not. That'll be up for others to think very seriously as to whether they would like to explore this. But at the moment, we have a paucity of knowledge in this area. And as I said, it may well be that pumping seawater on top of sea ice, you've grown more of it, but it's going to melt more quickly, and it might be the silliest idea ever, Meta. So we've got to go and it could be a good idea. So we've got to figure out the answer to that question.
Exactly. That's a wonderful project. And it reminds me of something else that's related to water on top of snow. There's a book called something about tree line, I think it is, by a guy named Rawlins. I think he lives in England. And he traveled around the northern, all of the countries in the Arctic, looking at where trees are growing. And he's very alarmed about the growth of trees. But also, one of the things he pointed out is that the people, the Sami people and the other indigenous people who are reindeer herders, are finding it very difficult now, because with global warming, there's more rain instead of snow. So they have snow, and then the rain will fall on top of it and freeze and make ice on top. And he said there, the reindeer try to go around foraging or digging into to try to get at the frozen grass underneath and so on, and it cuts their legs because there's ice on top, and they can't herd animals in the locations that they used to, because this ice on top of snow is a bad thing for them. So I mean, of course, I guess the real question is there a difference between salt water on top of snow and rainwater on top of snow? And you're not going to be looking into the latter, I guess.
Well, I mean, there is a difference in that the snow that's fallen is basically pure H2O, and the salt water that you pump on top of the snow is clearly salty, and it has a different melting temperature. So what you'll find is that when you pump seawater, let's say at -1 degree centigrade, it is cold, it's below zero. If you pump that on top of snow, what happens? Well, it doesn't melt the snow, because the -1 degree salt water is colder than the snow in terms of the melting temperature. So what you can actually find certainly after a period of time, is that it's filling the pore spaces in the basically the ice crystal air mixture. We call that snow, and therefore, and it's an amazing phenomenon that we've been observing, and then also looking at then actually what happens over a longer period of time. Then you might not just get melting, you might get dissolution of the ice crystals into the brine layer, the salt layer that you've created. So the physics of what's going on is also extremely rich. So that's part of the problem afoot that we're looking at from a research point of view at the University of Cambridge.
Wonderful. Are you studying the problem of the possible changing of the currents in the ocean? I'm every now and then get some ominous statement about the risk that things will happen, such as the changing of the Gulf Stream or the Humboldt Current or something of that kind. And I don't know. I mean, there's oceanography institutes that are doing work on that, but I don't think that most of the people. I think there's a lot more work done about the atmosphere and the aerosols and that kind of thing. But is there work going on at Cambridge about the danger of changing the ocean currents?
There is, but we have a team at the University of Cambridge in the mathematical modelling arena, doing sort of ocean modelling and ocean current modelling, but clearly they're not alone. There are very good centres, for example, Woods Hole and other scripts where there's a lot of work going on as well. And in fact, a colleague of mine or colleagues of mine going to New Orleans literally next week to a big ocean sciences conference where they will be looking at lots of modelling of the ocean, but they're part of that larger community.
Yes, I think we canceled one of our Monday meetings because everybody that we wanted to interview was going to go to that conference, and we couldn't catch anybody.
I know. Well, it's funny because that's next week in New Orleans, and there's also a conference on what I will call refreeze, but it's on geoengineering in Italy next week as well, which is where I'm heading. So there are two big conferences in two big areas, literally in the same week in the world.
Well, do you, with the perspective of what is going to happen there, do you have any hot tips about what I should look for? I don't know anything about anybody who's going to that one, but I want to know all of the proposals that are being floated about how to use geoengineering, especially in the polar regions. Do you know of anything new that anybody else is going to unveil there and share?
Well, I mean, I don't know of anything new. I'm going to be going and finding out. I mean, clearly there is the stratospheric aerosol injection that we haven't spoken about. So the release of sulfur or other materials into the stratosphere, marine cloud brightening. Those are the two big areas for geoengineering. But there will be those of us also talking about ice thickening, seabed curtains, and maybe the idea of protecting the glaciers through the distribution of reflective material to their surface. There may well be others, I don't know yet, who are looking at what you actually do to a glacier and the meltwater, about directing it away from the base of the glacier. Are there things that you can do there to try and reduce the lubrication effect that meltwater can have on a glacier to reduce the rate of slippage towards the ocean?
Now, when you say protecting the surface of a glacier, the thing that comes to mind is this woman who wants to sprinkle or somehow disperse small glass balls all over the Arctic. Is that the plan that you have in mind, or is there some other way being discussed of how to protect the surface?
So I have heard of that, and it's unclear just how realistic that is. I don't want to dismiss it because no idea should be dismissed without firm analysis right now. But the scalability of that in terms of just the amount of manufacturing of glass beads that you would need is significant. That said, in targeted areas such as the Himalayas, where marine cloud brightening might be rather difficult to do in the Himalayas. There isn't much sea around to go and create seawater, and also seabed curtains, ice thickening. None of those are going to work in the Himalayas. So the the levers, the options that you have there are rather more limited. And it may well be that some of these other ideas might be better suited to areas where there are even more severe problems and fewer options. So we will wait and see.
Okay, you haven't talked much about ocean iron fertilization, which along with, I mean, I think compatible with, and maybe almost involved in the iron salt aerosol project. The two things seem to me to be almost very, very compatible. But you haven't talked about that. Do you have a position on that, or do you have a point of view about why it's a good or a bad idea?
Oh no, I have a very strong position on ocean fertilization, which is the same position that I have for nearly all of these research ideas, and I think they need to be further explored at pace, because actually, if they work, they've got great potential. So no, I think it's really important that we don't throw anything away at the moment, and we do have a project. We call it, as I mentioned, slightly different than ocean iron fertilization. We call it marine biomass regeneration, but it's only because we're interested in a bigger question than just the amount of carbon dioxide that you might be able to sequester through the addition of iron, as an example, if that's the missing nutrient, the growth of phytoplankton, and the fate of the phytoplankton that you've just been able to stimulate and grow. No, we're interested in a bigger question, which is, why are there certain areas of the ocean that are deficient in nutrients? Because
that's a good question. Why? Give me an answer. I'd like to know.
Because if we can understand that, then it might well be that we can then sort of address an even bigger question of how we get a natural system just back up and running, doing what it should be doing, and having more phytoplankton growing and sequestering carbon dioxide. So you mentioned whales earlier on. We don't know what the relative impact of whales had rather, in terms of cycling of nutrients from depth to the surface by feeding at depth and defecating at the surface. Certainly, it is a mechanism, definitely, to get a cycling of nutrients. But there are other mechanisms too, just natural turbulent mixing. But as a result of the whaling that has decimated various species, blue whales being less than perhaps 1% of their original number. Secondly, warming of the climate overall, leading to an increase in the stratification of our oceans. And as a result of that, there being less natural mixing between the surface layers and the deep layers. So all of these are important questions.
But the whales are a big factor in that. I mean, the whales go up and down constantly and stir the oceans.
They do. It's not just the defecation. You're completely right. It's their movement as well. So, but one of the ideas is that if you were able to use the addition of nutrients to the ocean to get more phytoplankton to grow, which then gets more zooplankton to grow, more krill, and eventually more whales back into those areas, then the whales themselves will then end up doing more of the nutrient cycling that's missing at the moment. And in fact, therefore, the whole ecosystem then starts to be regenerated and taking in carbon dioxide. Now, that's a vision, it's a wonderful idea. And that's one of the projects that we are looking at the University of Cambridge. But we're not doing that alone. We're doing that in a collaboration with the University in Hawaii, the University of Southern California. There's a group in Goa. There's a consortium bringing different skills and capabilities to that project. And we have Professor John Taylor here at the University of Cambridge, who's leading the Cambridge part of this consortium. And it does show in a great potential, but we need more funding urgently to be able to progress the research to further our understanding, to really identify whether this is a scalable way of sequestering gigatons, because that's what the potential is for this approach. There aren't that many that get my pulse racing because of the scalability. But at the moment, there are big error bars and uncertainties associated with it. But we need research money going
But
into
that
that.
would you'd start with sprinkling iron filings, right? And you don't need much of that to start a phytoplankton bloom.
Well, this is one of the attributes of ocean iron fertilization is that the impact that you have on carbon dioxide for a given amount of material that you add to something. So I'm going to call it the ocean. The gearing is about 1 to 10,000 with iron, and the net result of growing phytoplankton and the amount of carbon dioxide that then gets potentially sequestered. But we've got to understand the fate of that carbon dioxide. Does it actually get to the ocean floor? So you might generate lots of growth, but if it doesn't get to the ocean floor, it just gets returned to the ocean, gets returned to the atmosphere. We haven't sequestered the carbon dioxide. So we've got to understand.
Well, yeah, but if you increase your fisheries, that wouldn't be a bad
well,
side.
it would be a good it's a nice co-benefit, but at the moment we're interested in understanding the climate impacts. But if that is the case, that actually the phytoplankton you grow eventually ends up as biomass on the ocean floor, the gearing is very, very high. Unlike, for example, other methods such as enhanced rock weathering, where you mine and grind rock and distribute it onto fields, then for every ton of that material that you and spreading on the fields, how many tons of carbon dioxide can you hope to convert into a carbonate and have it on the? And it isn't a gearing of 1 to 10,000. I used to think, of order 1 to 1. It's even less than that, depending on the rock that you're using. It's maybe 1 to a quarter. So that's just a lot of material that you are handling before you then.
We did a whole series on the use of rock dust on fields. Yeah, I have a whole series of shows discussing that. I did a series. What I did last year was 25 shows in collaboration with the Canadian Pugwash Group, which I've belonged to for about 40 years. And we did a series of 25 conversations about 4 different technologies that are purported to offer some hope for helping the climate. One being rock dust, and also the use of biochar and seaweed as amendments to the soil. The second being the use of carbon negative concrete, which is, I've just been having an argument with people about whether that's really carbon negative or not, and I think it is, but he thinks not. Anyway, then we were promoting urban forestry, not because it's going to reduce carbon from the atmosphere right away, or if ever, but because it will cool the cities, make it more bearable. And then the fourth was chilling the Arctic. And it was this last one that made me feel we need so much more work on that, as opposed to as contrasted to the other 3 interventions, that we need to have a whole series of shows specifically about these different technologies for hopefully chilling the Arctic again.
Well, and the reason why we have the Centre for Climate Repair at the University of Cambridge is that we're not just looking at one approach. We're looking at a multi-pronged sort of effort. And if any of them are found to work, then we will be very, very happy. Clearly, it would be wonderful if many of them are work, because but we need more effort on developing our understanding and developing the technologies on all fronts, especially in the greenhouse gas removal and what we call the refreeze space.
Mm-hmm. Well, good for you. That's exactly what needs to be done. And it is true that I feel that our mission, if we have any way of contributing to it, is by producing things, discussions at a level that the general public can follow and conceivably become interested in, and then trying to mobilize the knowledge that exists and get people to talking about things. So I produce these shows, and really where I would love to do more is try to penetrate audiences that don't know that we exist, and try to get people more interested in watching the shows and even discussing them, because we have a website with pages where people can enter their comments and carry on debates about the the very shows that they see. So I hope that we can, our work, your work and mine, continue to be as compatible as it seems that we are right now. I see no problem at all with what we're doing.
Well, Mera, I would be very happy to contribute again in whatever capacity you would like.
Well, let's look for the future and see what comes up. I'm sure that there are various ways in which we'll be able to cooperate, and certainly wish each other well, because what you're doing is exactly addressing the issues that absolutely require more research. And I certainly hope that we can speed it up. We need to hurry.
Thanks, Meta.
Okay, thank you so much. I've enjoyed this very much, and I hope to be back in touch with you sometimes soon.
Super. Bye-bye.
Blessings. Okay, bye. Project Save the World produces these forums, and this is episode number 588. You can watch them or listen to them as audio podcasts on our website, tosavetheworld.ca. People share information there about 6 global issues, and we welcome your comments too. To find a particular talk show, check the scroll list on the homepage or use the search bar. Project Save the World also produces a quarterly online publication, Peace Magazine, which now serves as a free-of-charge newsletter to help mobilize knowledge about 6 global threats to humankind. We gladly email the magazine as a PDF or link to any interested organization in the world that works to prevent a global catastrophe involving war and weapons, global warming, famine, pandemics, radioactive contamination, or cyber risks. Just email us at office@peacemagazine.org and we'll add your group's email address without charge to our list. Please type "subscribe my group" as the subject of your email. For individual subscriptions at $20 Canadian per year, go to pressreader.com on your browser and search for Peace Magazine.